we're going to look at 4 examples for multiplying radical expressions. The big thing that's important to remember when we're multiplying radical expressions is that we do rational to rational, radical to radical. So outside to outside, inside to inside. With these questions, we also are looking at polynomial expressions where there's more than one term. So we need to remember to distribute. So our 4 root 2, we're going to multiply to 2 root 5. And then we're going to multiply it to 6 root 3. And to the next one, and to the next one. So when we do the first one here, 4 root 2 times 2 root 5, we're going 4 times 2. Gives us 8. Then, so that's the rational to rational. Then we do the radical to radical. So the root 2 times root 5 is going to give us root 10. Then we do the same to the next one. So 4 times 6 gives us 24. Watch your signs. 2 times 3 gives us 6. 4 times 2, 2 times 8. 4 times 5, 2 times 32. So we're done the multiplication part, but now we have parts that can be simplified. For instance, root 16 and root 64 are both perfect squares. If we had anything where we could take out a factor that's a perfect square, we should also do that. In this particular case, we don't. So our 8 root 10 is going to stay 8 root 10. Likewise with the 24 root 6, because they have no perfect square factors. But 16 is a perfect square of 4, and 64 is the perfect square of 8. So from there, we're going to get 4 times 8 is 32, and 10 times 8 is 80. Our other two terms are just going to carry forwards. Twice over, in fact. And then we have negative 32. I messed up. Let's fix that. 4 times 5 is not 10. Don't know why I said it was. It is 20. So we get 20 times 8, which is 160. And so we have negative 32 plus 160, which is going to give us positive 128. We have no like terms we can get together. We have no terms that can be simplified, so that is as far as we can go on this question. There's our final answer. So our next one, same thing, we're going to multiply, but this time it's a binomial times a binomial, so we're looking at foiling. So 6 times 2 is our first step, which just gives us 12, because they're both strictly rational. Then 6 times 5 root 2, so the rational part, the 6, goes together with the 5, which is also rational, so we get 30. And the root 2 has nothing to multiply to it, so we just keep it as root 2. Then we do the 4 root 2 times 2, so the 4 and the 2 are both rational, that gives us 8, and the root 2 just stays. And our last two, we go 4 times 5, correctly this time, we're going to say it's 20. And then root 2 times root 2 gives us root 4. So from there, we've got two things we can do. We can simplify that root 4, and we can combine our like terms. So the 12 stays the way it is, but 20 root 2 and 30 root 2 and 8 root 2 can join. They're both negative, so that gives us negative 38 root 2. And the 20 root 4, well, root 4 is 2, so we can take that out and do the multiplication, which gives us 40. Our other terms I'm just going to carry. And then my last step, I want to combine my 12 and my 40. So 12 plus 40 gives me 52 minus 38 root 2. I have no more terms that I can simplify. I have no like terms I can get together. I am done. If we have a radical expression squared that is more than a monomial, we have to remember that It is the number multiplied by itself. So same as the previous one, we're going to expand that. So we're going to go 3 root 7 times 3 root 7, which is going to give us 9 root 49. You might be comfortable jumping a step here because root 49 is square root of 7. Sorry, square root of 49 is 7, so you might be comfortable jumping to this is 9 times 7, and that's fine if you are. Then we go 3 root 7 times root 2, so that gives us 3 root 14. And then root 2 times 3 root 7 is the same thing, just backwards. And then root 2 times root 2 gives us root 4, or 2. Again, if you're comfortable jumping to that step and just saying right away that it's 2, that's fine. We do have these like terms we can get together. 3 root 14 and 3 root 14 gives us 6 root 14. So then our 9 times 7 gives us 63. And 63 can be combined with 2. And you'll notice the part that we're not doing anything with, we just keep carrying forward. So now we have nothing left we can simplify. 14 can be factored, but none of those factors are perfect squares. We have no like terms to get together. So again, that's how we know we are done. Our last example is somewhat similar to the last two. We've got a binomial times a binomial. You will see that this one ends up being a special case by the time we're done it though. So 2 root 5 times 2 root 5 is going to give us 4 root 25. 2 root 5 times root 2 is going to give us 2 root 10. 2 root 5 times root 2 again is going to give us 2 root 10, but this time it's positive. And root 2 times root 2 is going to give us root 4. So our first and our last term have perfect squares in them, right? Root 25 is 5. Our last term, root 4 is 2. And you'll notice something happens with these middle two terms. One's positive, one's negative, and other than that, they're identical. So because they're like terms, we can combine them. Because they're identical but opposite signs, they cancel. So we're just left with 4 times 5 minus 2, which is 20 subtract 2, which is 18. So what happened in this particular one is we don't end up with a radical. And if you think about why, it's because that original expression follows our difference of squares pattern, right? This is a plus b, a minus b. And when we do that, those middle terms always end up canceling out. And that is how we ended up with no middle terms and no radical. So there we go. We're done with our examples of multiplying radicals.